In this video, I am going to continue with the solution of model question paper 2 with question number 8A, which is of module 4, which is the topic name is Modular Arithmetic. So here is the question. Using Fermat's little theorem, show that 8 power 30 minus 1 is divisible by 31. So by using Fermat's little theorem, we are required to show that 8 power 30 minus 1 is divisible by 31. So let us consider P equal to 31 and A equal to 8 here. So we should know the definition of Fermat's little theorem. You know that if P is a prime and P does not divide A, then by Fermat's little theorem we have A power P minus 1 is congruent to 1 mod P, or also it can be defined as A power P is congruent to A mod P. So in that case, I have defined what is A, what is P. I am going to just substitute over there. So it will be 8 power 31 minus 1 will be 30. 8 power 30 is congruent to 1 mod 31. So which is nothing but 8 power 30 minus 1 is divisible by 30. So this is the solution for question number 8A. Moving on to question number 8B. Solve the system of linear congruences using remainder theorem, that is Chinese remainder theorem, CRT we should use here. Using CRT, we require to solve this system of linear congruence. So whatever the given problem, you consider the value of A1, A2, A3 and N1, N2, N3. Here A1 value is nothing but 3, A2 value is 2, A3 value is 4. Similarly, N1 value is 5, N2 value is 6, N3 value is 7. So find the GCD of Ni, Nj, which is equal to 1 for all irrespective of I is not equal to j. Consider the value, smallest value n, that is n is nothing but product of n1 into n2 into n3, where we got n as 210. Now I am going to find out the value capital N1. N1 is given by small n divided by small n1, so which is equal to 42. N2, capital N2 is given by 35, capital N3 is given by 30. So after coming to know capital N, we can find out N1 into X1 is congruent to 1 mod N1. So as we know, we know that N1, that is 42, and small n1 is 5. So we got 42 X1 minus 1 is divisible by 5. So when it is possible, if and only if x1 is equal to 3 is the required solution. So similarly find out n2 x2 is congruent to 1 mod n2. So as we know that n2 values, we can substitute here n2 and small n2. So then we can decide that the solution for x2 is 5. Then 35 x2 minus 1 is divisible by 6 if and only if x2 is equal to 5. Similarly, substitute for n3 and small n3, we are going to get 7. We are going to get 30 x3 minus 1 is divisible by 7 if and only if x3 equal to 4. So finally, by Chinese remainder theorem, we have x mean, that is x bar is equal to a1 n1 x1 plus a2 n2 x2 plus a3 n3 x3. Substituting all the values, we are going to get x bar equal to 1, 2, 0, 8. Then x bar is congruent to x mod 210. So here we know that value of x bar is 1208. Substitute that value. So the value of small x is given by the 158. Similarly, we can get y value as 158, z value is also 158 is the required solution for the given problem. Moving on to next problem. Find the remainder when 175 into 113 into 53 is divisible by 11. So we have 175 is congruent to 10 mod 11. So when we divide 175 by 11, we are going to get the remainder as 10. Similarly, when I am going to divide 113 by 11, we are going to get 3. When I am going to divide 53 by 11, I am going to get the remainder as 9. So in that way, I have written the congruences. So by using the properties of congruences, we can have 175 into 113 into 53 is congruent to multiplication of 10, 3, 9 mod 11, the multiplicative value will be 270 mod 11, but 270 is congruent to 6 mod 11. So by using again property, we can write 175 into 113 into 53 is congruent to 6 mod 11. So therefore, the remainder of the product of 175 into 113 into 53 is 11. Is the required solution for the given problem. So I think you all understood how to solve the problems of modular arithmetic. So thank you for watching this video.